Hello, I am Sunita. Welcome to my class. Here I am going to discuss GPSTR science topics according to the syllabus. Here the topic is measurement of unit and dimensions. In that one particular important topic, measurement of small and very long distance object. In this class, we will come to know how to measure a very small like size of a molecule or size of an atom or diameter of an atom, then very long distance like distance between the planet and the earth, distance between sun and earth, how to calculate. Let us discuss in detail in this class. Next one is very important topic, measurement of longer distance objects. How to measure the longer distance object, let us study in detail. In day-to-day life, measurement of length is unavoidable, means you have to measure the length of each and every object. Small distance can be measured using a scale. Small scale we will use to measure the smaller distance, and it is expressed in terms of a meter or foot. Large distance like distance between the two cities, distance between two countries, then distance between the two states we will measure using the maps and also electronic device. These measured distance we will express in terms of a kilometer and also miles. Now going to step ahead for measuring the distance between the two stars. Distance between the two stars is not the smaller one. We can't measure using a scale. We can't measure using the map and electronic device. To measure the distance between the two stars, then between the two planets, then distance between the stars and planet, then distance between the earth and the moon. To measure the long distance, we will use some mathematical skill and technique. Here we will use triangulation and parallax method. Parallax method is the very important method to measure the distance of longer objects, and this obtained value is expressed in terms of a light years and astronomical units. Let us discuss in detail what is meant by a parallax method. Let us consider in detail what is meant by a parallax method. Normally human is having two eyes. The distance between the eye let us consider as a basis. When you want to see an object, normally we will use both the eyes also. But here if you want to discuss parallax method, if you want to see an object at a time, consider only one eye and see the difference between the position of the object. Then here for example we are considering an object pen. Then here viewpoint A we will consider as our left eye, viewpoint B we will consider our right eye. Then close your right eye, then see the object with your left eye. When you see the object with your left eye, then this object pen, it will appear over the green box, otherwise green background. Now close your left eye, then see the object like pen with your right eye. Then this pen appear over the red box, otherwise red background. Then why this, you can think why this difference of background it will appears different, and why the position of the object like pen, why it will change the position of the object when you see with the different eye. Then what is the changes, why it will happen, let us discuss in detail here. Here parallax is the displacement or the change in apparent position of the object when you viewed from two different points of view. Here also we are considering two different points, viewpoint A, viewpoint B. Then when you see the two different viewpoints, then this position of the object it will be changed. Once it will appear on the background green, once it will appear on the background red. Then this apparent position of the object when you viewed from two different points of view, the points of view have their own line of sights, and parallax is measured as half of the angle between the two lines of sights. Then using this parallax method you can find the position of this pen from your eye. Here if you see the object with your one eye, then you can see the change in apparent position of the object you will observe. Then this parallax method is used to measure the object for a very long distance. Let us discuss in detail with an example how this parallax method it will use to measure the longer distance of an object. Let us consider this one. Consider a circle with center, then draw two lines with the help of a center. The two lines, it is touching the circumference of the circle. Then you are getting the two lines AB. It will touch the circumference of the center. Then here these two lines make an angle theta. Then the distance between this O and A is nothing but the radius of the circle. Then this one we will call it as a arc of a circle. Then join these two lines, then you will get a chord AB. At this case, the length of the arc, it will be given by r into theta. Then here the length of the chord is less than the length of an arc. Consider next case, if the theta is very small, let us draw one more two lines. Then these lines making an angle theta. If theta is very small, then length of the arc, it will be equal to length of the chord. Then at this case, length of the arc, it will be equal to product of r into theta. Here theta we will measure in terms of a radians. Let us discuss in detail parallax method, how to find out the distance of a long object. Let us consider an example here. Measure the distance between the planet and the earth. Here S, it will gives the position of the planet, and AB are the two viewpoints on the surface of the earth. If you want to calculate to measure the distance between the two far points, you have to use a parallax method. In this parallax method, normally we will consider two viewpoints. Then here also we are considering two viewpoints AB on the surface of the earth. Then this planet and earth, they are too far from each other. Then S consider as the center of the circle, and D, it gives the radius of the circle. It is touching the surface of the earth at the point A, and D is the distance between the A and S. D is the radius of the circle, otherwise distance between the planet and the earth. Here also D, in another viewpoint, D is the distance between the planet and the earth. This AB, it is nothing but the arc length. B is nothing but the length of the chord. Already you know that planet is too far from the earth. Then this parallax angle, this theta, if it is very small, then this chord length, it will be equal to arc length. At this case, B, it will be equal to D into theta. Arc length, it will be equal to radius into theta. Here radius is D into theta. Then D, it will be equal to B divided by theta. D is the distance between the planet and earth. In this way, you can easily calculate the distance between the planet and the earth if you know the angle, parallax angle, and the arc length. Easily you can find out the distance between the planet and the earth. Here one more picture, it will show using parallax method how you can calculate the distance between the planet and the earth. On the earth you consider two viewpoints, then on the planet, then this planet, consider this is as a center, then this is as the radius, D is the radius, then this AB as the arc, otherwise chord. Here the planet is too far from the earth, therefore this theta, it will be very small. When theta is very small, then length of the arc, it will be equal to length of the chord. Then using this radius of the circle, easily you can calculate you know the radius, you know the theta, then arc length B, it will be equal to D into theta. Then using these values, easily you can calculate the distance between the planet from the earth. Up to here we discussed about measurement of long distance. Now let us discuss in detail measurement of very small distances. Very small distances like size of molecule, then radius of atom, How we will measure size of molecules and radius of atoms? Let us discuss in detail here. This we can't measure using vernier calipers, screw gauge and spirometer. Then here screw gauge, it is used to measure the diameter of a glass plate. To measure the length of a wire, we will use screw gauge. Then using vernier caliper, we can measure the diameter of a circular object. Then in the case of a spirometer, we will use to measure the curvature of object such as lens and curved mirror. Therefore, we can't measure small distance like size of molecules and radius of atoms using vernier calipers, screw gauge and spirometer. Then let us study in detail which instrument is used to measure the measurement of very small distances. Let us discuss here. Can we use optical microscope to measure the measurement of very small distances? Even optical microscope cannot measure these distances like radius of an atom, then size of a molecule. In optical microscope, we will use visible light whose wavelength is in the order of 6 into 10 to the power of minus 7 meter. Here you have to remember, in optical microscope we will use only the visible light whose wavelength it will be in the order of 6 into 10 to the power of minus 7 meter. Hence we can't see an object by an optical microscope whose dimension is less than 6 into 10 to the power of minus 7 meter. If you want to measure a small distance, if the dimension is less than 6 into 10 to the power of minus 7 meter, then you can't see an object, because in optical microscope we will use only the visible light whose wavelength it is in the order of 6 into 10 to the power of minus 7 meter. If we use these microscope to measure the distance of small object, then light will pass through such object instead of being scattered. If you want to see an object, then it has the visible light, it has to scatter the light. If it is simply pass through the object without scattering, then you can't measure the small distance. Therefore this optical microscope we can't use to measure a very small distances. Measurement of very small distance using electron microscope. To measure the distance as low as the size of a molecule, electron microscope are used. These electron microscope, here we will use electron beams, beam of an electron, then controlled by both electric and magnetic field. Then here electron microscope has a resolution of 0.6 angstrom. Then here you using this electron microscope you are able to resolve even atoms and also molecules. Next one, tunneling microscope. Using this tunneling microscope, it is possible to estimate the size of the molecules and also atoms. Here you have to remember, this tunneling microscope using less than 1 angstrom size of an atom. If it is less than 1 angstrom, it is used to measure the size of a molecules and also atom. Second method is molecular layer method. In practical method for estimating the size of a molecule of a liquid. This molecular layer method is the practical method to measure the size of a molecule of a liquid. The basic idea behind this method is to prepare a layer of one molecule thickness of a liquid on water. In this molecular layer method, it will be based on the preparation of one layer of one molecule thickness of a liquid on a water. This method is quite adequate for the liquids whose molecules are quite bigger in size. This method is used to measure the size of a molecule. If it is quite big, then it is easy to measure. The best example for molecular layer method is oleic acid is a very good example of such liquid. Estimating size of molecule of oleic acid. Let us here I given the steps to how to calculate the Molecular size of oleic acid, otherwise size of molecule of oleic acid. Here given the steps. These steps I will explain in detail in the next slide. Let us discuss in detail estimating size of molecules of oleic acid. Material needed: oleic acid, alcohol, water, lycopodium powder and scale. To prepare this solution, take 1 centimeter cube of oleic acid, dissolve this one in 90 centimeter cube of alcohol, then you will get 20 centimeter cube of the solution. This is the first solution. In this first solution, take 1 centimeter cube of this solution, then add 19 centimeter cube of alcohol, then you will get the second solution. Then this it will be 20 centimeter cube of the solution. Then here volume of one drop of the solution is how much we have to calculate. Then here then what is the concentration of this resulting solution will be. Concentration of the resulting solution, it will be 1 by 20 into 20, because first solution 20 centimeter cube, second solution volume of second solution 20 centimeter cube. Therefore concentration it will be equal to 1 by 20 into 20 centimeter cube of oleic acid per centimeter cube. Then here consider volume of one drop, it will be V centimeter cube. Let us consider an experiment. Here take some water in a beaker, then add, otherwise sprinkle, little amount of lycopodium powder on the surface of the water. This it will indicate the deposition of lycopodium powder on the surface of the water. Then add few drops of the resulting solution on the surface of the water. Then you can see this dark blue, it will indicate the solution, the drop of the solution, it will be evenly spread on the surface of the water. Then this drop of solution, it will be evenly spread on the surface of the water. Then it will form a thickness. That thickness it will be in the shape of a circle or a sphere. You know the circle, find out the area of this circle. How you will find out the area of the circle? Using the formula. You know the formula, area of a circle, it will be equal to pi into d, where d is the diameter of the circle. Let us consider this area of a circle, it will be a centimeter square. Then here this thickness of this circle, it will be correlate with the size of an oleic acid molecule. Then you have to find out the thickness or size of an oleic acid molecule. Let us discuss in detail how to calculate the size of an oleic acid molecule. Let us calculate the thickness of oleic acid mathematically. Then volume of one drop, it will be equal to V centimeter cube. We don't know the volume of one drop, therefore consider as V centimeter cube. Then volume of n drops, it will be equal to, multiply this one with n into V centimeter cube. Then amount of folic acid in volume of 1 centimeter cube, it will be equal to concentration of the solution. How much amount of oleic acid it will be present in volume of 1 centimeter cube of the solution, it will be equal to concentration of the solution. Then it will be equal to 1 by 20 into 20 centimeter cube. This one already we studied how you got the concentration of the solution. Then amount of oleic acid in volume of n into V centimeter cube. Here you are having the concentration for 1 centimeter cube. If you want to calculate for n drops, then multiply NV into this concentration of the solution. Therefore n into V into 1 by 20 into 20. Multiply NV into 1, you will get NV divided by 20 into 20 centimeter cube. You know the formula, thickness it will be equal to volume divided by area. You know the volume, n into V divided by 20 into 20 divided by area, we don't know. Therefore consider as a. Then shift this one to numerator. Then NV divided by 20 into 20 into A centimeter. Then thickness of oleic acid, it will be equal to NV divided by 20 into 20 A centimeter. In this way we can calculate the thickness of an oleic acid. This is very easy method to calculate the size of an oleic acid. Thanks for listening my class. Send me your valuable feedback. The topic we discussed here, measurement of long distance object, otherwise measurement of short distance object. This topic is very important. This topic they may ask in descriptive type questions in the exam. Therefore, understand the concept, revise, then easily you can write in the exam.